So I'm going to go ahead and record this video now. I wasn't able to make the video a couple days ago, so I'm just going to go ahead and talk about it now. Let's see if I find the right spot here. Okay, so neutralization reactions was the part that we weren't able to cover. And this shouldn't take too long to go through. But a neutralization reaction, I think what I talked about in class was if you neutralize something, neutralize basically means you're going to get rid of, or you're going to react two things together so that they balance each other out, that sort of thing. A good example of this is neutralizing your stomach acid. So if you have heartburn or acid reflux or something like that, a lot of times you can take a Tums. There's too much acid in your stomach, and the Tums is a base. It's just a pill, a powder, whatever, in tablet form that you can chew up and swallow, and it's a base, and it will neutralize, it will react with some of your stomach acid to make it neutral. Okay, so that's what's happening with the neutralization reaction. The general form of any acid-base reaction, I should say a strong acid, strong base reaction, even weak acid, weak base reactions, but we're not going to talk about those this year. So strong acid, strong base are going to react with one another to form water and some sort of salt. Now, with salt, when we say that, that's just the chemistry way of saying an ionic compound that's formed from an acid-base reaction. Okay, so that's what a salt is. It doesn't have to just be sodium chloride NaCl. That's a very common example of a salt, but it could be a different ionic compound as well. Okay, so an example here is hydrochloric acid plus sodium hydroxide. And you can kind of think of these as double replacement reactions, which I don't know if you remember this from earlier in the year, but it's a wife swap, basically. So they switch places. And remember, the positive ions are in the front, the negative ions are in the back of the formula. So you could just kind of switch the positive ions around, and that will give you the new formula. So what you end up with, the H goes with the OH now to make H2O. Okay, you can write that as HOH if you want to. The Na then goes with the Cl and forms your salt, sodium chloride. Okay, and so that's the basic form of any neutralization, acid-base neutralization reaction that's going to occur. So it's not all that difficult. The other thing you have to make sure of at the end is that the equation is balanced, and this one already is. It's all one-to-one stoichiometry, so this one's nice and easy. We don't have to worry about balancing anything here. Okay, so tricky problem here. How could you produce the salt CaBr2 by using a neutralization reaction? Okay, so what it's saying is, how could you, instead of making NaCl as a product, how could you make CaBr2 as a product? Okay, so what you have to look at here is, let's look at our example equation up here. The chlorine in the NaCl came from the acid, right? So we should probably do the same thing down here. The bromine should probably come from an acid, and so it would make sense that the acid it's going to come from is HBr, right? So instead of HCl, we have HBr. That means when it forms a product, it's going to be bromine instead of chlorine. Okay. The sodium was attached to the hydroxide. It was the base. All right. So following the same pattern down here, the calcium would be attached to the hydroxide. Now calcium has a 2+ charge instead of a 1+ charge. So we're actually going to need 2 hydroxides when we make that formula. So HBr plus CaOH2. And then you just do your wife swap again. The H and the Ca kind of switch places. So the H goes with the OH to form water. Always forms water. It's one of the products. And the other one is whatever's left over, which in this case is the Ca and the Br, which because calcium's a 2+ charge and bromine's a 1- charge, it forms CaBr2. All right, now we're not done with this one because this one needs to be balanced. So we need to put a 2 in front of HBr to balance out the bromines. And that gives us, let's see, Well, and then let's look at the oxygen, because that's only in one place on each side. The hydrogen is in two places on the reactant side. There's two oxygens on the left side, on the reactant side. So we need to put a 2 in front of the H2O to balance the oxygens. And then I actually took care of our hydrogens as well, because we've got 2 hydrogens here and 2 hydrogens here, so that adds up to 4. So that's it. That's how you would write a neutralization reaction. It's going to make CaBr2 as the salt. Hopefully that makes sense. Oops. Okay, what's your reactants needed? Okay. So another example here. Write the equation for the reaction between sulfuric acid and lithium hydroxide. If you want, you might pause the video here and see if you can figure this one out for yourself. Okay, so let's see how we did here. Sulfuric acid and lithium hydroxide. So first of all, we got to remember what sulfuric acid is. Okay, the first thing you would notice here, hopefully, there is no hydro in front of this. Okay, so if there's no hydro, it means that we're dealing with a polyatomic ion of some sort, right? So an acid always has H plus in the front, or H in the front. And then sulfuric, if it has that ic ending, then it means that the polyatomic ion ends in 8. Ic and 8 go together. I ate something that was icky. So we're talking about sulfate. Okay, the sulfate ion, which if you look on your polyatomic ion chart is SO4 2 minus. Okay? So when you crisscross the charges there, you end up with H2SO4. That's sulfuric acid. Okay? So the reaction between sulfuric acid and lithium hydroxide, lithium is just Li, obviously, and lithium is a 1 plus. Hydroxide, if you look that up on your periodic table, that's a 1 minus. So this is just going to be a 1-to-1 ratio here, LiOH. Okay, and then we do our wife swap again. The hydrogen goes with the OH, H goes with the OH to make H2O. And the stuff that's left over, we got lithium and we've got sulfate. Okay, now again, lithium, the 1 plus charge, sulfate is a 2 minus. So when we crisscross charges, we're going to end up with Li2SO4. And then we have to balance this one as well. It's not balanced yet. So we need to put a 2 in front of the LiOH. And that threw off our oxygens. So then we need to put a 2 in front of the H2O. And I think that does it. Okay? So that's the basic idea of neutralization reactions. Hopefully that makes sense. I don't think it's going to give you all that much trouble. Yeah, and then we were on to titrations. So we will see you in class.